Okay, welcome everyone. My name is Pieter-Jan. I'm from Iniris, from Belgium. I'm a business developer here, and I will be taking you through the training of the SmartgridOne. So we'll jump right into it. Um, we'll actually start with a hardware description. So what our controller looks like, what's included in our controller. Um, So to start, we have our SmartgridOne controller. We have a couple connectivity options, including RS485 connections, on-off switches. So we have the relays, the digital inputs as well. And on the other side of the box, we have our Ethernet connection, which is always necessary for our controller. So we always want a stable internet connection with cable. And then we also have a couple USBs that allow um, a sub device to be connected to the controller, or extra devices to be connected to the controller, but also P1 directly to the controller. So we have a simple cable P1 to USB, which we could connect to this. There's also an HDMI port on this. You do not have to take this into account. You do not have to do anything with this. This is purely for us. Um, so that makes that we can connect our box, or we can communicate with our box through Modbus TCP, Modbus RTU, through APIs, through MQTTs, even through the OCPP of the charging stations, and P1 as well. Now, the external hardware I talked to you about, we have a few options here. So we have an RS485 to Ethernet connection, as well as the relay, as well as the P1 to Ethernet connection. So these are mainly for assets which cannot be controlled, um, or which cannot be hooked up directly to our controller. If we have, for example, a inverter who only communicates through Modbus RTU, so we need the RS485 connection, but the controller is too far from the inverter, then we could use like one of these extenders to put them through the network. Do keep in mind that they have a different protocol. So when adding the asset, you would have to choose for the specific protocol, but I will come back to this with an example later. So the same goes for the relay contacts, so the heat pumps, and same goes for the P1. Now the relay contacts are controlled through the I'm sorry, the heat pumps are controlled through the relays. So that means we go through the SmartGrid ready interfaces of the heat pumps. So we could steer about and control about 9 out of 10 heat pumps which is installed these days. Now we have another add-on for the controller. So this is an RS485 to USB connector. This allows the user to have multiple RS485 connections on one controller. Now, it is possible to daisy chain multiple RS485 connections to one single controller, but if one would like to have more RS485 connections, then this is an option for you. Now, I've talked about Modbus RTU and Modbus TCP once or twice now, so I'll just give you a brief introduction about what the differences are between one another, and what the advantages and disadvantages are. Now, the Modbus RTU is the physical connection that's made between the box. So it's the RS485 connection between the box and your asset. Now, this is a wired connection, so it's always stable. Do keep in mind that we have resistors at the end of about 120 ohms. I will come back to that in just a second. and it is limited in distance as well. So the maximum distance you could go in practical distance is about 100 meters. Um, we also have a practical limit about the number of assets you could connect to that. That's about 10 pieces before there's too much noise on the chain, uh, which does make for a more difficult installation process. Now, if you use Modbus TCP, on the other hand, you are dependent on the network, but in theory, you could have an unlimited amount of assets connected to to the controller. Now, this is really simply done just by finding the MAC address on the same subnet. Uh, so this is a really simple method for installation, most likely preferred by most installers, except for those who want a stable connection. Now, to get back to those resistors, the end resistors, um, they are already inside the controller. So there's a little switch that tells you which is on, which is off. Do not mind the black dip switches. These are for the older models. All the new ones have the red ones with on written on them. And then here's an example of how it's actually set up. So it can be, it has to be at the beginning of the chain with an end resistor of 120 ohms, which you need to put yourself at the end. Now, we are working on a solution to put our EMS in a slave function as well. This is something to be looked at at the end of Q3, Q4 2025. Now, the colors of the LED are as follows. So we have, yeah, if it's off, it's not powered on at all, so it doesn't get any power. If it's blue, the controller is still booting. If it's green, everything is normal. If it's purple, it means we have no internet connection. And red is actually a factory reset in process. Now, first things first, if you want to access the controller, if you want to access our dashboard, you need to have an account. You can create this yourself, or you ask us to create you an account. Now, the first thing you need to do when you have an account actually is claim your controller, right? So we go to the application, we add our controller based on serial number and verification code. This is a fairly long number, so even when asking for support, we always ask to create a ticket so that we have the serial number written down so we don't make any mistakes on the phone. There's always an extra sticker in the box in case you lose the one which is on your controller. Once logged in to the controller, you can do that with two steps. So one is through the app or through the portal, which is fast, quite simple. It's just a button. You can always do it remotely. And the other one is through a fixed IP address. For the people who want to connect their controller through a fixed IP address, our manufacturer is called WeBrain. We always have a fixed MAC address, which you can see on the screen here. Okay, you can find it, the IP address with a IP scanner if you'd like to have. Now, do keep in mind that you're free to use any browser you would like. You just surf to the IP address and enter the IP of the controller. Now, for the commissioning itself, there's something I need to say here. For the fixed IP address, the normal login is admin. So you can always access the controller. You can always change this later in the settings of the device. For the commissioning of the installation, I will talk to you about the different steps you need to take in the commissioning interface of the controller. Well, first we start with the login. So as you see here, I told you already, you log into the controller with admin if you're on a local IP, but if you go through the application or the remote control, then you just enter your Insights account username and your password you received or you made yourself. Now, the installation wizard is the first thing that pops up when you click login to your controller. So these are meant to subtract essential information for us. These are like 5 simple questions we ask you to get an idea of the installation. Now, the first one is it's actually here as well on the home screen, so you can always reinitialize it. So the first one is the main circuit breaker. As you can see, you just fill in the amps you have. The second one is the grid settings you have. You choose single, three-phase, any other you have. The next screen you get are the contract values. Contracted values are necessary if your energy provider has put those on you. If you can't export or import more than certain kilowatts, then you can enter those values here. There's also a safety margin included in case you would like to have a little margin for us to respond to the system. Now, the next one, I'll dive later into detail on this, but these are the default working modes, the algorithms of our controller, which you can enter here. You're already seeing some of those here, but I will explain these in detail later. When I click next, I still have the option to use the data saver mode. This is mostly for people who are using 4G, 5G setups. We always recommend a minimum of 5 gigs per month. Please add an extra gigabyte per month if you have more than 5 devices. For each device, you add 1 gigabyte. You can put this on if you have 4G. I recommend leaving this off if you have a stable internet connection. Last thing we ask you is a location. Now, why this is for the weather. So we connect through the local API of local weather stations. Based on that, we do the prediction, so we can do forecasting. And there's also the matter of dynamic pricing. So we need to know in which country you are to do to have the right dynamic pricing set. So these can either be the Apex spot or the Node Pro pricing. That's why we ask. Now, then you're ready. So your home screen looks like this. You see the serial number, the software version. If the cloud connection is okay, you can test your internet speed. You could go through the setup wizard again, and then here you could see which steps you've taken in the setup wizard, if they are okay or not. Step 6, you don't have to worry about it. This will disappear in the controller because that is something we do for you. Now, the second thing you want to do is add your devices, of course. You can start the device wizard. We've created a wizard for this, which allows you to add any asset you like. So for example, the energy meter, the solar inverters, the batteries, the heat pumps, the charging stations, gas meters, water meters, building management systems. So you take your pick here, for example, the solar inverter or the energy meter. These are examples of energy meters. So you pick your supported brand, and then you click on the type of connection you'd like to make. So we support, as I said before, both Modbus TCP, Modbus RTU, or the P1 port. So here you see the option to have the RS485 converter as well. If you're using this converter, you need to select this option because it's a different protocol. Now, next up, you could always choose for your model, But if it's not included, you could just simply select my model or device is not listed, and then we give you all the protocols we have of that brand, so you can try and troubleshoot yourself out of this. 9 times out of 10, this will work because most brands use the same protocol for their series of inverters. So as you can see, like all the hybrids from Atronics use the same hybrid inverter protocol. Next up, you get a manual from us. If there are any further steps which need to be taken, then these will be mentioned here, but only if it's necessary. Okay. Um, After that, there are a few follow-up questions. If there are, like, for example, only solar panels, or if there are any batteries with solar panels, or if there is an energy meter connected to the inverter, we will read it out automatically. Okay. Next screen we get are the scan parameters. You do not have to fill this in. You can just click search and let us do all the work. But do keep in mind that if you know, for example, the bus address, so as you see here, it's 12247, we will scan all these addresses. So it will take some time. Now, if you know the location of your device, you could just put like 240 to 240, and then we will find it immediately. You can also do a slow scan for older devices. It sometimes takes a little longer for them to respond, so that's why we have this button. We are waiting a little bit longer for them to respond. Now, we prefer to add it by MAC address, but you can always add your devices by fixed IP as well. Once completed, you have a list of known devices. So here you see an energy meter, for example, the Home Wizard, which is connected. And then if you have like an inverter or a heat pump connected to it as well, it will show in this list. Now, if you look at the top of this screen, you see the different tabs we are going through right now in this training. So first we had the home, now we're at devices, and I will go through each of these tabs separately. For the devices still, we can always test a device once we've added it. For example, this charging station of Alphen, we can always test it to see if it works, to see if it listens, if we control it. Now do keep in mind, if you test a charging station, a car needs to be connected with a minimum of 6 amps. For the device itself, you could always change the settings of a device specifically. Now, if we are looking at this P1 dongle from Home Wizard, you can see that we put it to the grid connection. It can measure other things as well. So if you have a different energy meter with which you would like to have, for example, an energy production read out or heat pumps read out, those can be chosen as well. Okay. There's some factors here you need to answer if it's mono or three-phased, and if the meter is forward or in reverse. Okay, third tab are the groups. Here we've created a hierarchy ourselves. So when you add the devices, we create this tab ourselves for you to check. Now, this is a visualization of how the energy flows, of which devices are placed where in the installation. It's like a monitoring tool to create the hierarchy of things. We've used the example of a single line diagram. I'm sure you guys know this better than I do, but it's just to give you an idea of how we perceive things. So on the right, you can see the structure of how we imagined this to be. To give you an example, you can see it on the bottom of the screen already, but this is automatically generated, so you don't have to do anything for it. Um, so to give you a really short example of how it looks like, the single line diagram, you see the distribution grid, you see the home wizard P1, Wi-Fi P1 meter, and the main switchboard beneath that. So that's how we um, visualize those things. You could always manage these groups yourself. You could always add different things. You can always remove different things. For the next tab, we are in external data sources. This is to add an external signal who sends set points to our assets or to our controller, which we send to our assets. Okay. The external signals are more likely the imbalance signals, which is what they're most commonly used for. Um, to give you an idea of these imbalance signals and who supports them, these are some of our partners who send us these signals. So you are free to choose with either one of these. The next step are the settings of the controller itself. Now here you see the limits and the main circuit breaker, the grids, and the grid kind. You've added these in the setup wizard before. So in the beginning of the installation, you've already added these. You can view this here. You can edit these. Now, the next is the default working modes of the controller, which you can always edit. Again, I'll jump into these later in this training. For the password change, this is only for people who've gone through their controller through a fixed IP, so they can change their password. There's also a two-factor authentication in the controller if you would like to use it. An automatic reboot period is also included. It's not done automatically, but you always have the option to reboot. Now, you can always add PV installation details. This is to make our prediction a lot better. So you can add the tilt, you can add the azimuth of the production size, and based on that, we can do accurate predictions of your production. Now, for the internet usage, so it says here what we've downloaded, what we've uploaded, the past 30 days, and also the data saver. You can put it on or off here. For the network configuration, these are standardized for DHCP. If it's still static IP, please remember the IP address because we cannot help you if you lose it. Do keep that in mind. If it's no longer reachable, we can't help you. So there's only two solutions for this. There's the direct connection to your PC and there's the physical reset button. Now, the direct connection is a lot more complex than the physical reset, but still, if you have a fixed IP, please remember the IP, remember that we can't help you. But yeah, keep it to DHCP if you want to be all easy and set. For the remote service connection, we use the default port 1194, sorry, and we also have some backup settings which can be taken so you can save them onto your device for later. There's no real way to restore a backup onto a new controller. We're working on this. We're looking into like the beginning of Q4 to make this possible. So this is coming. You can always check for updates in case you've missed one. But keep the box enable automatic updates on if you would like to be automatically updated by us. There's the reboot function as well for a manual remote. restart, and there's a factory reset as well, which removes all the data. Lastly, we have our advanced settings. Our advanced settings, I'm going to talk to you about this a little bit because I'm sure you guys will dive into these, but just so you know what you are doing, there's a little button in the middle of my screen called Custom Optimization Aggressiveness. So this button here, Reduced Risk, um, it's to tell you the aggressiveness of our trading on the Apex spot price. So you can put this to a more aggressive trading strategy. Also, at the bottom, you see a grid limit safety factor, another grid limit safety factor, in fact. You could always change these, okay? This is a guided value. We always multiply your values by zero 0.9 to have a 10% safety factor. But if you want to change it to 1, be my guest, and then we will follow the default net export limit. Um, yeah, you can't put it to 1.1, so don't try. It's like kind of a child lock on there, so you guys don't get to play with this a lot. Now, also in the advanced settings, you have an option to enable grid support from energy storage, so from the batteries. This is an example of the battery, which shows the battery supporting the grid when there's a high demand in charging stations. The last tab is an about in the settings. About just gives you the general information of our controller, and also what is interesting here, it gives you which ports are available. So if you're on location not with the client and he asks, I want to have another heat pump connected, you can always check from a distance whether the heat pump relay is still free or not, so you don't have to remember everything which is connected there. There's also a change log, which includes the new integrations, the new features, so all the updates of our latest you can find it there. One of the last tabs we have is the data tab. This is a static page. So if you click open a meter, for example, we give you every single point of data we get out of that meter. Do keep in mind it's static, so you have to refresh it if you want to have new data. There's also a manual, of course, for all of this, what I've just told. It's all documented on the site docs.iniris.io. It gives you the configuration from A to Z, all the supported devices are there, the certificates are there, the wiring and connectivity guidelines are there. Manuals for each brand in particular are there, so you can find everything you would like to know right here. A little bit about the algorithm now. So the algorithm is a base set of rules based on the settings you've put into your pilot. So these are based on the factors you put into your setup wizard when we first connected the controller. We always respect the import limits and export limits, of course. But those are the rules for the baseline. If you want to go above that, we have control modes which target the entire group of assets. As you can see here, it's a small preview of what we are going to dive into next. So we are going to start with the batteries, then the PV inverters, then the EV stations. Now, when we say do not control, as you can see in the left corner, we truly mean do not control. Okay, we always guard any current and power limits, but if you tell us to don't control anything, we will not control anything. We will not regard any limits. Okay, to start with the batteries, we have a minimize self-consumption mode, which actually aims at 0 on the meter. So we always try to regulate it down to 0 as closely as possible. Secondly, we have the peak shaving exclusively enabled. So um, these allow you to charge and discharge between certain values you put in the controller yourself. And then we have the minimize cost function. So the minimize cost function uh, is the principle of this is actually to charge at the lowest price and discharge at the highest price. So this is actually the energy trading we are talking about. These are the Apex spot prices we are talking about. If you put it into this mode, we will do that ourselves. Now, keep in mind you have to allow us to do the energy trading. So it's a small little box you'll have to tick. There's also a minimum price you get to set. You don't have to follow this price. You can edit this on your own if you want to be a more aggressive trader on the Apex spot. So this is the principle that's explained again for the decision making, and if the price difference is not big enough, we will not trade. Do keep in mind we always have the starting cost and the running cost of the battery included in our calculations. This is an example of what the client sees. So, for example, we discharge when when the prices are high in the morning, and then we charge over the day when the prices are low because of solar and stuff. So we always show this to the client as well. Okay. For the PV inverters, again, we have this minimize cost function. It comes back with every asset we have. For the PV inverters, we also have the option to limit the feed-in to the capacity we put in the setup wizard. The minimize cost function, what does this include? This includes PV curtailment, in short. So we will provide the energy to all the different assets. We will provide it to the battery, to the EV charger, to the house. But when the prices go negative, we limit to our own consumption. So these are the limit exports I talked about. It's produced as much until the limit is reached. For the charging stations, we have a maximize self-consumption mode, which actually means charge as much solar as possible. We have a minimize cost function. Again, here it means we try to charge with the cheapest energy as possible. We try to look ahead for the pricing as well. And then you have our load balancing mode. So we charge to the grid limits. Now, for the EV charging stations, there are a few exceptions or things we need to watch out for. There's always 6 amps, which needs to be available for the charging to continue. There are some brands who support stopping or pausing between the charging, and then starting back up again. For these ones, you can add these options yourself to the different chargers if they can go to 0 amps or not. To give you an idea of the suspended charging, you see it the second to last. There it's set to no. You can set it to yes if you know the charger can support it. If the battery is allowed to charge, if the EV is allowed to charge out of the battery, that is your choice as well. So here it is set to yes. You could always put it to no if you don't want the car discharging into the battery. There's also 5 types of priority. We have our highest priority all the way down to our lowest priority. This decides the order in which the chargers get priority. Okay, so here you can see an example of this. It's always dynamically distributed, so we will adjust the power if necessary, and then we have our battery for grid support, which I showed you some time ago. We will support the battery with the grid. There's also different schedules we can put inside our application. We have different strategies for this. So one of these is you can set your own charging schedule. So for example, you come at the office at 8 in the morning, you have to leave at 5 in the evening, and you need 400 kilometers. Okay, and then we will decide what is the best and most economically interesting way to charge your car for you. So we could stop the session in between for a few hours, or we could start later on the day to see, okay, it's cheaper than charging now, so we're going to wait a little bit, or we can charge from the battery and stuff. These can be adjusted inside the application. For heat pumps, it's a little different. We have some standard moduses, which are called boosting, blocking, or we have a normal operating mode for the heat pumps. Um, Basically, the normal on, so the boosting mode, we only switch the contact off if the consuming is not interesting. For the blocking is the other way around, so we only switch the contact on when the consuming is not interested. Now, for the heat pumps, most people like to leave them in the normal operating mode. To give you an idea where you can select these. When you add a heat pump, for example, you will get the option to have a normal operating mode or boost or block mode. Okay, there can also be minimum boost times, maximum boost times, minimum waiting times for the heat pump to be efficient. These can be adjusted here. For the relays, it's the same thing here. Now, the control modes of the heat pumps, the boilers, and these on-off loads are basically all of three of them are the same. So we have our maximize self-consumption, with which we've divided also into different sub-moduses. So this is purely which we try to do as much as possible on PV. But you have three different modes here. You can try to do only when there's a production surplus and low cost and low consumption costs. You can always allow offtake from the grid, or you can tell your heat pump to only schedule when there's a surplus. So no offtake from the grid. Again, for the minimized costs, the same principle here as with the others. You boost at low prices, you block at high prices, and then for the peak shaving, these give you a limited flexibility, but it's one at a high generation or off at a high consumption. For the last mode of control, so control by a third party or through an API, these are added in the tab external signal controls. So these can be third parties like Uso, Frank Energy, Edme, or you could do it yourself. We have an Ineris API. It's a public API you can access. So you can send the set points yourself to our controller, which we send to the different assets. Now, the thinking behind this is that we always follow your signal, or we always follow the signal of the third party. And only if the external signal drops out, we fall back to the local control mode, which we've just discussed. There's also the thing about the network. So the data usage, I've covered it 2 times already, but we need 5 GB minimum when we run 4G. If we are controlling through an API for the imbalance, then I strongly recommend actually you don't use a 4G connection, but rather a fixed internet connection. Now, there are sites where this is not possible, but please contact us if that's the case, and then we'll figure it out together, because we need a heavy uh, mobile mobile contract for this. Okay, so the data saving function mode is also an option. So here you see once again the network usage, which is being shown. Now there are a couple ports, TCP ports, which we need when we are in a bigger installation. Some corporate networks don't allow inside communication. That's okay, but we need a couple outside ports. So here are some of them summed up, actually all of them summed up. For stricter networks, we usually recommend the IT service to set up a separate VLAN and then throw all the assets in that VLAN. They usually know what they are doing, so just ask them to set up one of these, and so you can connect everything safely and easily. Okay, so once you set everything up, you can go back to your application, and this is what it should look like. So if we have, for example, a EV charging station connected, a battery connected, we have our grid meter and our PV production plant read out, you can see all the different kind of streams here. So this is a fairly simple application. This is also meant for the end customer. Now, for the end customer, we have added some nice features into this. If we click, for example, on the battery, then we will see like the energy that's charged and discharged during the day. So you can see the state of charge here. You can see the historical state of charge, but also the futuristic state of charge of the battery, which is quite unique. So this is based on the dynamic pricing we can do, based on the weather predictions we can do. And that's thanks to your location. Okay, so that's why we need the location to do these predictions. We can see the actual power here, also the charging, discharging power of the battery here, and also the energy prices. Now, keep in mind that this is always data from the actual plant itself, so it's the total battery that's here, and then we have different sub-devices on which we can zoom in. Okay, so you can always zoom into a level. Now, there's also a second way of going through this this application, which is through the button on the top here, on which you can back to overview, or you can just use this button here. To give you an idea, the usage, so the usage exports, and the self-consumption is here as well. The historical consumption, but also the predicted consumption is here. Now, for the EVs, we've talked about the different smart schedules we have. Now, to show you where you put these smart schedules into place, you go to the sub-devices 2 times until you're on the socket level, and then you can just add these different kind of rules. So if you want to add one yourself, a repeating rule, then you add the different dates you would like to add this, and then you say you would like to have, for example, 400 kilometers by 7 in the evening. So you can add these ones, or your client can add these ones yourself, and that's one of the only things that we allow the end customer to do. Now, what we're showing to the end customer is the planning as well. So here you can see what we are doing with and without guidance, and then the dynamic prices are shown here as well. The dynamic prices can be configured by the end client themselves, but it don't necessarily has to be that way. You will also have the right to remove those things from his application. What the client can do is actually see his current site or select a different one if he has multiple. He also has these buttons. Now this one on holiday, this means that the controller isn't retaining information uh, about the um, about the length that it's turned on. Okay, our controller learns every day, every second, and we keep all that information. So when this is turned on, we do not intend to learn new patterns. So if you're going on holiday for a longer time, then we would ask you to put this button on. Again, it's not necessary. It's just helpful if we see, okay, after 3 to 4 days, it has dropped down significantly. We will adjust our forecasting and our planning based on that. When the client comes back, then okay, we will adjust again. It's just a nice feature, a nice to have for us, so we don't have to change our algorithm or planning, excuse me. Now, these next two things, like the energy cost settings and the admin settings, these are actually removable for the end customer. So when you assign them the role of end user, they don't see these settings. They only see these settings, these two settings, when you assign them the role of an installer or an admin. Okay, here he can adjust the different pricing. So this is based on the tariff, the Apex spot. He can add his extra costs here if you'd like to choose to, or if you would like to do this for him, you can adjust everything here. You could always choose like for a fixed tariff or your own. Now for the admin settings, here you can see the different control modes which can be adjusted. Same goes for production and stuff. Same goes for the heat pump. You can add these here yourself. Add these. You can edit these here yourself. So that's why we do not like the end client to play with these, which is why we are taking it out of their hands by default. I will show you where to have these rights and where you have these rights in just a minute. Okay, you have your maximum feed-in power, your grid limits here, again shown. So these are the basic rules which we always play by. So that's basically it for the application. So this is called the SmartgridOne environment. So this is only for your end customer. This is the only thing your end customer sees. You can always access this view, but we are in a web application for the moment, in a web portal for the moment, which means we can switch from the SmartgridOne environment to the SmartgridX environment. Now the SmartgridX environment allows us to have a look at our entire installation, and on top of that, it allows us to look at all of our different sites. To give you an idea of how this is done, we've divided a couple installations here, for example, the residential installations, then we have our CNI installations, so installations that are purely solar, charging hubs here. You can divide these yourself. Now on top, you see if there are any alerts, alarms set out. You can adjust these alarms yourself. So you can put an alarm at, for example, if the plant isn't producing for more than 48 hours, then I would like to have an email about that. That's these alarms that you put here. They are recorded in this tab in the incidents. You could always send reports to the client, so we could create a template for you in which you can send different reports to the client on a daily, weekly, or monthly basis. And then there's this one right here, the user management. Now, this may seem overwhelming, but if you look at one site, so for example, we have the Emiliana test site here. If I want to add a end customer to a site, I just add the email address here, and he will get an invitation to the test site. Now, this will not record anything because we have a test site. We also have the installer and the admin role, and each role has its different rights, and you are in control as well of that. So here you can see who gets to do what and who gets to do who. You can adjust these yourself. Now to go back to our sites to give a little more insight on this. If we go to, for example, a site with batteries, we can choose what we see here on the top as well, which is done through this. So you can just add what you would like to see. And if you go into detail at the site, you just click on it and look at your overview. Now, this is a lot of data on each other, on top of each other. It just shows how everything correlates to one another. But you can always turn those off if you would like and make the comparison between two single ones. Now we give you all the data we have here. So you can zoom into everything, you can search for everything. Now the way you go deeper into detail on this is you can always go to descendant devices, have your power meter in front. So we give you like a heat map as well. So you can see what's been done day to day. So on top you have like your Fluvius meter in Belgium, and you go down like a waterfall. It's actually like a waterfall kind of principle. So you have your digital meter, your switchboard, which is in your switchboard. Under your switchboard, you have different hybrid inverters, and in your hybrid inverter, you have different batteries. So you can see you can go all the way down. Actually, you could go all the way down to string level if you would like to, and if the inverter allows us to, and adjust what you would like to see here. Now, we know that this was quite a way of getting there, so that's why we've created a navigational button. If you click on this, and so you can see you can just jump to the battery really easily. So that way you don't have to navigate through all these through all these tabs. Okay, great. Now, how does this all connect together? So, if you're looking back at the SmartgridOne, SmartgridX. So SmartgridOne is for the end customer. It's an application on their phone and at which they get an invite to once you have entered their email address. It's free to download actually from the Google Play Store and the App Store. You can easily switch to your SmartgridOne and SmartgridX platform. This is only for you, your dashboard, your web portal. This is only for you, for the installer, for the wholesaler. So if you click on this, you get taken to the interface of the controller, which is here. So this is the controller which we talked about in the beginning of the training. So here you can see it in a live situation. To give you an idea of the initial setup wizard, if you go through it, we have like our normal amps in which we enter. We have our three-phase system here, limits, our control modes, our data saver, and then our location. That's it. That's all we need from you. Now we add our devices here through the device wizard. So we get to add an energy meter. So you just choose in the list what you would like to see, what you would like to do. As you can see, there are a lot of brands here. Same goes for the solar inverter. So you just choose your brand here, and then your way of connecting. Is it Modbus TCP or Modbus RTU? You tell us what you would like to connect. If it's not there, you could always try through the protocol, and then we will search by MAC address, and then you just select the device you want to add. Same goes for the heat pumps through the SmartGrid Ready interface, the charging stations as well, the battery systems as well. And then in the settings, we have our local control modes, or default working modes, which we can edit here. Okay. If it's necessary, you can start the wizard. So as you can see, we do the day ahead forecasting, the pricing. We push the prices ourselves to the controllers, but you can add external signals from any partner here. So that's how everything hangs together. Now there's a last part I want to discuss with you. There's the thing about troubleshooting, which are the most common mistakes which are made in our system that I'm going to share with you. Now, we always show, if you are adding a device, what is going wrong. So you can always check the logs, check the detailed logs, if you want to see what you are doing wrong, if there is a connection at all, if we feel any connection, if their connection refused. All this is shown here in the detailed logs. Now for TCP, there are a few common mistakes which are made, which is, for example, that the connection is refused, which means that you still have to access, like for example, a brand's portal and enable TCP, which is necessary for some brands. Another error, sometimes another error we usually see is a different port is chosen, a wrong device is chosen, or a wrong protocol is chosen. So here you can see at the bottom, connection refused, which is why we need the TCP connection to be open. For the RS485, we have a few different errors. You could check the baud rate, the parity bits, the stop bits even. Even a physical connection can be made wrong, so do check the wires if they're not inversed. And again, the device and the protocol can also be wrongly chosen. As you can see here, this means that the device is not connected at all, or you're using the wrong protocol. There's also an exception, as you can just see at the bottom of my screen. If there's an exception in the driver, it's best to contact Iniris, then we know this is an issue for us. So the device statuses are always shown to you. If there's like a problem with the BMS or with PCS and stuff, we will show you the measurements here, and we will tell you we're not currently controlling the BMS because of, for example, a heat issue. Okay, so to finish, if you can't find a device because it's not supported at all in our list, then we have a device integration request form, which you can always enter. The only thing we ask, there are two things we ask of you. We ask to have the protocols ready for us and sent in actually by you. And we always ask for a testing location, a test site, which is vital because we will not pick up the integration request if we do not have a test site available. Okay, but if we do not support any brand or any product you are working with, which you would like us to add, you could always submit your request here. We're always open to new ones. Uh, Same goes for any new feature requests. You can find everything in here. Also on the docs website, so the docs.iniris.be, please look on this website as well. When you do the installation, you can find all your an answer to all your questions there. Okay, so to finish up, this is the QR code to a certification test. Once you've completed the test, you will get a certification from Iniris. You could send in your logo, send in your picture, and we could mention you on our website. Thank you very much to everyone who made it through the end for paying attention, and we'll see you guys later.